Hello, this is group 16 and the title of our project is table detection and extraction. So, um, as part of this project, we have implemented various methods that include table detection and extraction from the images. Tables are a convenient way to present data, but extracting data from tables in image format can be challenging. So, presently there are various algorithms which fulfill the task of table detection, but they do not still do the task of content extraction from the images itself. Now, moving on to the various methods that we have looked into, there are 4 methods that we have majorly followed. So the first one is the CNL table detection method, in which we have defined our own model in order to detect the image, the table from the image with the bounding box values. So firstly we have annotated the data to obtain the bounding box coordinates, and later on we have put this bounding box coordinates in our augmented them with our labels also. In order to train the model, we define these labels along with the bounding boxes, so that at the end the model could predict the bounding box coordinates and provide us with the table bounding box coordinates, so that it can be utilized further for the table for the content extraction process. So the model had 2 convolution layers and 3 FC layers, and the data set was imported customly. While training this while training this particular model, the output is supposed to be the table presence or absence marking with the binary value and the bounding box values. Though at present no deep learning model could provide answers in such format, deep learning models are used to classify deep learning models are used to classify either single label or multi labels. But here we require some bounding box values which we cannot obtain as the final layer outputs. So this particular path requires further more research, and as part of that research, what we have come up is that the loss value could be calculated and the model can be optimized on top of that particular loss value. Loss value will be the difference between the annotated bounding box coordinates and the predicted bounding box coordinates, and these bounding box coordinates will be obtained from the logits values from the layer of the model, that is not the output layer. Now, moving on to the second method, which is easy OCR method. So as part of this particular method, what we have done is there is one we have taken an input image which contains a table. It looks like this. So we have installed the easy OCR library and other required libraries to implement this particular method. So at first we have find the contours and applied polydp, and moving onwards we have found the bounding rectangle which has the least area also surrounded by the edges itself. So from there onwards we obtain these particular cells, and these particular cells are arranged in the same order as they are shown in this particular image. So all we had to know beforehand is the number of columns that we need to put in our data frame. So and the titles or the column names headers will be kept automatically. After obtaining the data frame that is extracted from this particular image, we have also created our own ground truth label data frame and created the Jaccard similarity as the evaluation matrix for this particular method. The Jaccard similarity value that we obtained is 0.66. So this method is useful in obtaining the content from the image, but the bounding rectangles obtaining these bounding rectangles and working with these particular cells is quite tough, and this method would fail when there are sub columns within a column. The structure or the hierarchy would be required in this particular method that we can look as a future scope for this method. Now moving on to the last 2 methods, those require YOLO algorithm, and these are the 2 different versions of the YOLO algorithm, which is YOLO 5 and YOLO 8. it is observed that YOLO 5 is slower than YOLO 8, and these are the precision curves for YOLO 5 and YOLO 8. The first one, this one is YOLO 5 precision curve, and it has value of 0.92, and YOLO V8 has value of 0.931. There are other evaluation metrics as well for the YOLO V5 and V8 comparisons. We have mean average precision value at 50% IOU and 50 to 95% IOU, and the recall values. For all these values, we have observed that the YOLO V8 performs better. Also, there are additional features in YOLO V8 YOLO V8 version. One of such additional feature is our anchoring box. So though YOLO V5 and YOLO V8 are useful in table detection, but they are not useful in content extraction. So limitations of the YOLO algorithm would be the content extraction. Future scope for this particular project is that for the easy OCR method, we need to modify or optimize the algorithm to obtain the bounding boxes faster. For CNN model, we need to research the method to obtain the bounding box values from the layers. And YOLO V5 and YOLO V8, these are table detection methods, not the table extraction methods, and we need to look further into that. Developing novel tool which can scan the image or any PDF and convert the detected tables into MX Excel sheets is the objective that we are trying to achieve here. We have also mentioned all the references and GitHub libraries that we have used here.